How do we know that two species are related if their common ancestor is no longer alive? How do we know what happened on Earth before humans showed up? Sometimes the answers to questions like these are right beneath our feet. Look in the right place and you'll find fossils, traces of organisms that were once alive and that with time were preserved, usually in rocks. And here's the remarkable thing.
When we get fossils out of the ground, they have features that are shared with features found in living organisms.
So tucked away inside rocks that are thousands or millions of years old, we find fossils of bones and shells and leaves that resemble those in organisms alive today. They give us a record of how life on Earth has changed over time. It's not complete, however, because not all organisms get preserved and not all fossils get found.
So the more of these fossils we have that we can place on the tree, the more it tells us of when different features of organisms evolved.
Pull a fossil of a dinosaur femur or thigh bone out of a rock layer that's, say, 68 million years old, and you know that dinosaur must have lived about 68 million years ago, and you can compare it to the femurs of animals both extinct and alive today, which will give you an idea of how those organisms are related, and how the femur in particular has been adapted to suit new organisms in new environments over and over again. The fossil record provides strong evidence for evolution. It shows us that evolutionary change tends to be gradual. It gives us physical proof of extinction and of single species splitting into two. And it contains creatures that are transitional forms between one group of species and another. This is where you're being sent now, to a place where living things become rocks, and those rocks become clues that tether the ancient Earth to the modern one. Prepare to dig.